Have you ever felt like you're just drowning in repetition? Facing a task that needs doing maybe 1,000 times.
Yeah.
And each time there's just a tiny variation, but each one is absolutely critical.
Yeah, absolutely.
Think about like validating new software or making sure some complex system works for every single user setup. It's not just slow. It's this sort of hidden bottleneck, right? A huge time sink that can just cripple development testing cycles.
It really can.
But what if there was a way to, break free? To automate that tedious stuff, but also dramatically boost accuracy and coverage.
Well, that's where this topic comes in.
Exactly. Today, we're diving deep into a really powerful solution, data-driven testing. And look, this isn't just another buzzword. It's actually a fundamental shift in how software gets verified. It turns those repetitive tasks into these streamlined, efficient processes.
That's a great way to put it.
So our mission for this deep dive is to unpack exactly what data-driven testing is, why it's just so important, and crucially, how it actually works. We're pulling directly from the sources you provided, so get ready for some really practical insights that might just change how you think about testing forever.
That's right. Because the core challenge, what we're often up against in software development is ensuring just bulletproof quality. Across an almost infinite number of scenarios, your software has to handle countless inputs, user actions, different conditions, and do it gracefully.
So many variables.
Exactly. And data-driven testing, it's a strategic, almost elegant answer to this. It lets teams be incredibly thorough without just getting completely swamped. And the real aha moment here, the thing that can truly transform how you test, is this simple but actually profound idea, separating your test data from your test logic.
Okay, yeah, let's unpack that. So at its foundation, data-driven testing, or DDT, you'll hear it called that, it's a software testing method. And the key is the test data, so the actual inputs in what you expect to happen, the outputs. It's all stored entirely separately from the test script itself. We're talking tables, spreadsheets, maybe even dedicated databases.
Right.
And the magic, really, is that a single test script can then run tests for all the data it finds in that external source.
Yeah.
You might also hear this called table-driven testing or parameterized testing.
Yeah.
But it's all about that crucial separation.
And that separation is the key. It's also important, I think, to distinguish between data-driven testing, the method itself, and a data-driven framework.
Okay, good point.
While DDT is the concept, the framework is the automation testing framework that makes it actually happen. This is where your input values get read dynamically from specific data files, like you said, an Excel sheet, maybe an XML file, a CSV, even a database sometime.
Right.
And then those values get stored as variables right inside your test scripts. What's really cool about this framework approach is that it empowers testers to build both positive and negative test cases, all within one single lean script.
Ah, okay. Both sides of the coin.
Exactly. Think about the sheer breadth of testing you can cover with that kind of efficiency.
Okay, that's where it truly gets compelling, isn't it? Because think about the classic pain point this solves. Testers, they often have multiple data sets, sometimes hundreds, maybe even thousands, for just one single test scenario.
Oh, yeah, definitely.
Traditionally, making individual tests for each of those, it's incredibly time-consuming. Almost prohibitive sometimes. Like, can you imagine testing a login system with 1,000 different username and password combinations manually?
Ugh, no, that sounds awful.
The old ways were certainly laborious. You could, create 1,000 separate scripts, one for each data set, run them one by one.
Right, the brute force method.
Or you could manually change the values in the script itself and just keep running it over and over.
Also tedious.
And as our sources point out clearly, both ways are just laborious and time-consuming. It's like trying to, fill a swimming pool with a teaspoon.
Yeah, that's a good analogy. And that's precisely why this data-driven framework offers such a powerful third way, the ideal approach, really. Instead of all that tedious, repetitive manual work, you just import all that data from an external source, like a well-organized Excel sheet.
Okay.
The framework then, sort of intelligently, fetches each row of test data one by one and executes that single script against it. The sheer amount of time and effort this simple separation saves is, well, it's astounding.
Right.
It means your data lives independently from your test scripts. That lets the very same script run against an almost endless array of input combinations. Generating results with this, just remarkable leap in efficiency. It's a real paradigm shift, moving from manual effort to something truly scalable.
Okay, so that definitely covers the why. That makes a lot of sense. But the natural next question is, how do teams actually build one of these frameworks? So let's maybe walk through it using that common example you mentioned, testing login functionality, which our sources detail pretty well.
Okay, yeah, sounds good.
So step one is basically identify your test cases. For login, this means mapping out all the scenarios. Successful logins, obviously with the right credentials, but also all the different failure types, right?
Mm-hmm.
Incorrect username and password. Incorrect username only. Incorrect password only. And even those edge cases, like leaving the username or password fields blank.
Yeah, covering all the bases.
Then, step two, create detailed test steps. This is the sequence of actions that stays the same, no matter the login attempt. Launch the app, enter username, enter password, click the login or OK button, and then the crucial part, check the results. Verify what actually happened.
Right, that core flow.
Those are the fixed actions your test will always do.
Makes sense.
And that leads directly to step three. Create a test script. Since those steps are common, you build a template script. Think of it like pseudocode, maybe something like driver.get, URL of the application, then txtbox username, .send keys, some value, then txtbox password, .send keys, some other value. And finally, if, next screen shows up, print success, else print fail, something like that. This script is just the skeleton ready to be filled with data.
And this is where that genius of separation really kicks in. Step 4. Create an Excel or CSV file containing all your input test data.
Ah, the external file.
Exactly. This file is where all those different username-password combinations live. And importantly, it also contains the expected results for each combination. It's completely separate from your script, which, by the way, allows even non-technical folks on the team to help expand test coverage just by updating a spreadsheet.
That's a huge plus.
Definitely. Then finally, step 5, modify the script to loop over that input test data. So instead of hard-coding values like validucer or wrong password, your script reads them dynamically. Imagine it, again in pseudocode, something like this. For each row in the Excel file, input username is your read Excel, current row, username, and column. Input password, you'd read Excel, current row, password column. Then use those variables. txt box username.send keys, input username, txt box password.send keys, input password, input ves, then check the outcome. If expected result from Excel matches actual result, print success, else print fail.
Got it. So it grabs a new set of data on each pass.
Precisely. In each loop iteration, it reads a new row from your Excel file. The power here is immense. It's really clear. That single test script can now loop over countless test cases just by adding new data rows to your Excel file. It covers everything from valid logins to weird edge cases, all without ever needing to touch the actual script logic itself. It kind of democratizes the ability to expand test coverage.
Wow. Okay. So with that framework laid out, what are the real tangible wins we're looking at here? What does this all mean for, your ability to ship high-quality software?
Well, the advantages are pretty significant.
Yeah, data-driven testing offers huge benefits. For starters, it makes testing apps with loads of different data sets, especially during regression testing, incredibly efficient. All your test data, your verification data, it's neatly organized in one external file, totally separate from the test case logic.
Keeps things clean.
Right. It also means actions and functions in your test suite can be easily reused across different tests. You drastically cut down the need for creating brand new test cases and scripts, because the same core logic gets executed multiple times, just with different inputs.
Reuse is key.
And critically, any changes you make to the script, they don't affect the data. Changes to the data don't affect the script. That separation is golden. Our sources also mention best practices like, using realistic data, carefully coding the navigation flow in the script, using meaningful data for virtual APIs, using data for dynamic checks or assertions, and definitely testing both positive and negative outcomes.
And building on that, if we think bigger picture, depending on the tool you use, these test scripts can often live in a single centralized repository.
Ah, okay. Easier management.
Exactly. It makes them way easier to understand, maintain, manage, especially across a team. Another really compelling advantage is that some advanced tools can even automatically generate huge amounts of test data.
Oh, interesting.
Yeah, incredibly useful when you need large volumes of just random data, maybe for stress testing, saves significant time on data prep. And this is vital. DDT isn't just for one phase. It can be performed in any phase of development.
Flexible.
Very. It gives developers and testers this really clean separation between their application logic and the test data. leads to much more maintainable code bases overall. And this raises that critical question about efficiency you mentioned earlier.
Yeah.
How can you leverage existing work for even more value?
Right.
Well, a key best practice here is the ability to repurpose those data-driven functional tests you've already built for things like security testing or performance testing. You get much more bang for your buck, so to speak.
That's a really powerful argument for efficiency and reusability. But, like any robust solution, it's probably not perfect.
Yeah.
There must be downsides, right?
That's fair, yeah.
What's the other side of the coin for data-driven testing?
That's an important point to cover. While it's incredibly powerful, there are definitely considerations. One major factor is that the overall quality of your tests really depends heavily on the automation skills of the team implementing it.
Ah, okay. Skill dependency.
Yeah. If the team lacks strong coding and automation expertise, they might struggle to build a truly robust and maintainable framework. Also, validating the sometimes huge amounts of data you're using, that can become a time-consuming task in itself, especially with complex interconnected data sets.
Right. Managing the data itself becomes a job.
It can, yeah.
And what about the upfront investment? Or maybe ongoing maintenance? Is this something a team could just jump into easily, or are there significant hurdles?
That's a natural question because there is an investment involved. It's not just a switch you flip. Maintenance over time can become a significant issue, primarily because of the substantial amount of coding often needed to build and manage the framework effectively.
So it requires coding chops.
It often does. High-level technical skills are frequently required. A tester might even need to learn a whole new scripting language to really do it properly and maintain these frameworks long-term.
Okay.
Furthermore, you generally need more comprehensive documentation, especially around script management, the test infrastructure itself, and how you report results in detail. And on a very practical level, maybe a bit mundane, but you'll even need basic tools like a simple text editor, like Notepad, just for creating and maintaining those external data files accurately.
Right.
It's definitely a strategic investment, not really a quick fix.
Okay. So bringing it all back together then. Data-driven testing is clearly a powerful automation framework.
Yeah.
It fundamentally reshapes how you approach verifying software quality.
Mm-hmm.
Its core strength seems to be its elegant simplicity, right? Storing test data separately, tables, spreadsheets, allowing for just immense efficiency and scalability.
Yeah, that separation is key.
It really does seem to resolve that lengthy, time-consuming process of creating individual tests for every single data set, just by liberating the data from the functional tests. And while it really excels at letting you test applications with multiple data sets, especially during that critical regression testing,
Right.
its ultimate effectiveness does seem to rely quite a bit on the automation skills of the team putting it in place.
That's a fair summary. And if we connect this to the bigger picture, data-driven testing, it isn't just about streamlining software quality. It's actually a powerful lesson, I think, in how separating concerns, specifically data from logic, can unlock tremendous scalability and adaptability. And not just in software, but in any complex system.
That's an interesting thought.
Yeah, think about it. Whether you're managing projects, conducting research, maybe even just organizing your personal finances.
Yeah.
How might this principle, this idea of data-driven approaches, apply to other areas of your work or even your life? Something to ponder.
Definitely food for thought.
Well, thank you for diving deep with us today.